steel island, 23 stories tall, operating in water 5,000 feet deep, drilling 6 miles into the earth on a high-tech treasure hunt. This is the engineering marvel that satisfies the world's thirst for fuel. It's 30 million pounds of men and machine.
These men can get hurt every day. This is men versus iron. And iron does not give.
But when a monster hurricane pounds through the Gulf, knocking out rigs, shutting down a quarter of the U.S. oil production, it's up to this crew to get the huge machine back out to sea and back on mission, pulling off one of the most difficult engineering feats imaginable: drilling for oil under the sea. "150 miles off the Louisiana coast, in water more than a mile deep, a floating factory rises over the Gulf of Mexico. It's a space-age machine, engineered to search for treasure 100 million years old. Oil, the black gold that drives the modern world. This super rig, called the EVA 4000, is uniquely designed to find it. One of the largest movable structures the world has ever known. It has to execute a modern miracle: drilling for oil under the Gulf of Mexico. Much of the world's economy depends on it doing its job. One offshore oil field can pour out 250,000 barrels of crude in a single day. Enough fuel to fill the tanks of 250,000 cars. But that's just a fraction of what the marketplace demands. Every day, around the world, we burn up to 80 million barrels of oil. And unless things change, in the next 50 years, the energy demand is expected to double. There are only 100 deep-sea exploration rigs in existence. It takes 4 years and $500 million to build a new one. This means the EVA 4000 is in high demand. It's fully outfitted to roam the deep waters, far from shore, in pursuit of black gold. The EVA's deck is the size of 10 basketball courts. Its drilling derrick is 170 feet high, and it floats in a hull capable of keeping all 30 million pounds afloat. The scale of this Goliath boggles the imagination, even today. It would have been inconceivable in the days of the first oil well just 150 years ago. 1859, Titusville, Pennsylvania. The first oil rig in history strikes crude just 69 feet below the surface. From this American strike, the quest for oil spreads to every continent except Antarctica. For decades, wells on dry land satisfy world consumption. But the demand for fuel grows. Many oil fields are sucked dry. So companies extend their pursuit of crude offshore in oil-rich seas like the Gulf of Mexico. These dots signify the Gulf's oil rigs and platforms. From 1960 to 1990, 4,000 platforms sprout in the shallow waters just off the coast. But demand outstrips these shallow water reserves. Oil companies go farther and deeper offshore. Beyond the continental shelf, in depths approaching 8,000 feet. And engineers construct machines no one dreamed possible.
The offshore oil industry is some of the most advanced technology for anything, anywhere in the world.
The EVA 4000 is among the biggest and toughest of the new breed of drilling rig. It's exploring in waters so remote they were once thought impossible to develop. But there's a price to pay for being so bold. This far out on the ocean, these machines face constant threats. Explosions, pounding waves, and the most dangerous enemy of all, hurricanes. August 2005. Hurricane Katrina looms on the horizon. In just a few days, it will drown New Orleans and devastate the Gulf Coast. But another drama unfolds out at sea. 4,000 oil rigs and pumping platforms stand totally exposed in the Gulf. The eye of the hurricane is on track to pass right through them. Katrina barrels toward the floating platforms, forcing more than 20,000 oil workers to evacuate. 90% of the Gulf's offshore oil wells shut down. The EVA 4000 is caught in the crosshairs of one of the most powerful and destructive hurricanes on record. 170-mile-per-hour winds, 80-foot waves.
The winds are pretty fierce right here. The rain is still coming down in sheets, and as you can see, the waves are crashing in. And this storm is far from being over.
The storm pounds the oil fields for 48 hours. When the weather clears, the scale of the devastation stuns the industry. More than 50 platforms damaged or destroyed. Half a dozen big rigs have broken free from their moorings. One rig has blown 80 miles toward land. Another crashed into a suspension bridge in Mobile, Alabama. A third washed up on the shore. A total loss. In the days following Katrina, the entire world feels the storm's impact.
We're all in one oil market, and when you have a disruption in the United States, the price of oil goes up instantaneously. You know, Germans were paying more, Japanese were paying more, Chinese were paying more. We all pay the price when there is a crisis in the world oil market.
Gas, of course, is a precious commodity right now. There are very few gas stations open, and the lines are tremendous.
At U.S. pumps, gas prices shoot up as much as 50 cents a gallon. The EVA 4000 needs to get back on its mission fast. Every day this disruption continues means over 1 million barrels of oil are not making their way to shore. The repair crews waste no time. They'll work as fast as humanly possible to get this monster back out to the Gulf, where it will have to pull off one of the most astounding engineering feats of the modern world: getting oil from miles under the sea. The EVA 4000 drilling rig, damaged by Hurricane Katrina, towers over a Texas shipyard. Every day the $500 million giant is shut down means another well not being drilled. And in 24 hours, one oil field can supply the daily needs of 4 million people. The frantic push to get the damaged rig back online begins. Shipyard workers get busy fixing the EVA 4000, one of 20 behemoths damaged by Hurricane Katrina. It's a gargantuan task. They must check over every inch of these enormous machines. Rigs that are uniquely designed to drill 5 miles deep into the Earth's crust while floating on dangerous seas. Repair workers will examine the 4 key components that make this rig work. The hull, the anchoring system, the drilling deck, and the derrick. The hull is a pontoon, a kind of steel life preserver, with a 350-foot wide triangular base supporting 6 large columns. Each section is filled with air to keep the entire 15,000-ton structure afloat. Atop the hull, the deck. Bigger than a football field, strong enough to hold up to 2 million pounds of drilling pipe. 2 160-foot cranes, and a full-sized helipad. But the deck and the hull just provide the stage for the main event. Towering 15 stories above the deck, the derrick. Its job: lower a drilling shaft that stretches all the way to the sea floor and beyond. It can support 1.5 million pounds of steel, more than the weight of 75 fully loaded school buses. Holding the whole rig in place out at sea. The anchoring system. 9 enormous winches, 3 on each corner of the hull. They pull back tight on steel mooring cables, anchored to the ocean floor up to 1 mile below. These cables snapped during Katrina, sending the rig drifting free. This rig is lucky. It's fixable. Other platforms were hit even harder by one of the worst hurricanes in offshore oil history.
They tore a bunch of rigs up. It's worse than hurricane in oilfield history. Ooh, I landed on one last week. I landed on one helicopter, and the whole derrick fell over. It's on the ocean floor.
The EVA survived its wild ride intact, but it needs help. The #1 challenge: repairing the mooring lines that anchor the rig in place. This is what it takes to tie down a super rig. 3-inch wire cables hooked to chains with links larger than a man's head. Steel cable forms the top end of the line, spooled back and forth from the winches on deck. Steel chain is at the lower end of the line. Much heavier than cable, the chain provides added weight to the line and connects to the anchors. Most people couldn't lift a single link of this monster chain.
This chain is 2 3/4 inch chain. This link will weigh 72 pounds, and there's 4,250 foot of this chain. So in total, you want to have somewhere around 1 million pounds for each one of the 9 legs that's physically fitted onto the rig.
Crew members must connect the steel cable to the heavy chain. Like everything on the super rig, hooking them takes a mixture of engineering and brawn. These lines can handle up to 1 million pounds of tension. So strong that they could withstand the combined power of 5 747s without giving way. The crew attaches an 18-foot anchor weighing 13 tons to the end of each of the 9 chains. Their pointed flukes will dig 40 feet into the seabed. They'll try once again to keep the rig in place. But Katrina has demonstrated that human engineering does not always triumph over nature's power. After weeks of hard work, the moorings and the hull are ready for action. But there's one more critical component to check: the super rig's moneymaker, the derrick. High above the superstructure, iron workers move inch by inch to make sure over 1,000 bolts are tight, undoing the damage inflicted by the hurricane winds that rattled the tower. It's a methodical and precise high wire act that many regular iron workers can't stomach.
Regular iron workers, they can't even do it because see the girts are turned sideways like that. It's not flat, it's hollow.
On the derrick, the girder beams are turned sideways to withstand the stress generated within the tower. But a sideways beam leaves an awkward surface for the workers to walk on.
So a lot of them, like some of the iron workers come try to do it, they can't do it because they can't walk on their beams like that.
The workers move up and down the derrick, dangling precariously, tightening bolts as they go. One false move, and they could plunge 170 feet to the deck below.
Boy, ain't this something else, huh?
With the last bolt tightened, the EVA 4000 is ready to return to its drilling site. Tugboats will drag it out to sea. But moving it from the dock is tricky.
Craig, we want to be on the dock while they're unhooking that.
If it starts to drift in the river current, nothing will be able to stop it.
One barrel, Greg.
Boy, let that one go. They're coming around now. You got to get up on top.
Workers anxiously untie the landlines, holding the EVA to the dock.
Hands there. Watch your hands when you're slacking.
Guys on the mat, get out of the way before he catches up.
Put some slack. Slack.
The 15,000-ton rig drifts free. And for an instant, it's unclear which way it will go. It's like trying to tow a 23-story building. The tugboat engines need all of their 13,500 horsepower to take control of the beast and head for the open seas. With an average speed of under 4 miles per hour, it'll take them 5 days to deliver the rig to the Gulf's deep water.
Our first operation when we get back offshore will be to run the anchors and the chains and then restart our operations that we stopped when we were offshore.
This petroleum hunter will need all of its parts working together to accomplish an incredible engineering feat. drilling for oil that could be buried 5 miles under the sea floor. It's been weeks since Hurricane Katrina devastated the Gulf of Mexico. In the crucial offshore oil fields, damage is heavy. The entire world feels the loss when the Gulf's daily output, 1.5 million barrels of oil, is drastically reduced. An EVA 4000 drilling rig is trying to get back online fast. But first, it's got to find the oil field somewhere out here. Miles off the Louisiana coast, beyond the continental shelf. This is the deep water, up to 6,000 feet deep. Vast fields of precious petroleum lie somewhere below the seabed. But where? The rig needs a treasure map to find them. One analyzed in top-secret meetings using the latest in high-tech tools. To hunt for oil reserves, geologists bounce sonic waves off the seabed to create sonar snapshots of the rock layers below and turn the data into a 3-dimensional image. This is what an oil treasure map looks like. There's no X that marks the spot, just faint geological clues, such as domes of salt that indicate where oil might be hiding. The stakes are high, the outcome uncertain. These high-tech charts are only an educated guess. In the deepwater Gulf, it's always a gamble. No one's really sure they've found oil until they strike it.
There is nothing that is a guarantee from the data that we can capture, seismically or any other way. Basically, you've got the hypothesis. Drilling the well is really the last test.
The rig is in place over a potential oil field. But the drilling can't begin yet. First, the rig has to be tied to the seabed by 9 enormous anchors. It's a risky operation. When you're working with machines this big in waters this deep, nothing's easy and everything's dangerous.
These men can get hurt every day because this is still men versus iron. And iron does not give.
It can be a dangerous place. And you want to go home to your family in the same condition you come out to the rig in. When we're greasing the chains or the gears or anything like that, just watch your body placement, watch any caught betweens.
A crane swings one of the 13-ton anchors onto the deck of a support ship. This is just one of 9 anchors needed to hold the EVA 4000 in place. The support ship carries the anchor to the dropping point over a mile away.
Hey, tell me when it starts rolling. I'll start out slow and I'll bring out the speed. All right, coming in.
Just the anchor line alone weighs more than 450,000 pounds.
Hey, Jimmy, are they going to have to check that anchor?
You probably see if it goes by itself.
Number 7 anchor winch. Come in, Jimmy Romero.
Yeah, go ahead.
Yeah, roger that. That's 8,250 feet of wire out. I'm all stopped and everything's locked down.
The 240-ton cable must drag the anchor from the deck of the ship. A crewman gives the mooring lines one final check before taking cover. It'll take 15 minutes for the anchor to hit the bottom, nearly a mile below. The rig is now stable. The EVA 4000 can home in on its target. Drilling in waters far deeper than once thought possible.
Used to be when I first started, deep water was 2,000 foot. Now 5,000 foot is considered almost shallow water. So it's come a long way.
This is a work environment more inhospitable than outer space. Far too deep for humans. The record depth for a scuba diver is just over 1,000 feet. The EVA 4000 works in seas 5 times deeper. Down this far, the pressure would kill a human, crushing the worker's lungs. But the drill operators need a pair of eyes on the sea floor to make sure the drill hits the target and to monitor the work. Engineers have custom designed a remotely operated vehicle, or ROV, to handle the job. It's capable of enduring forces pressing down at over 2,000 pounds per square inch. An undersea robot built to go where no human could survive.
It used to be divers did all the work. If you lose an ROV, you know, for whatever reason, it's a machine. It's a workhorse. You know, it's not like losing a life. They're much better than a diver.
The ROV will be the eyes and hands of the crew working far above in the control room. An onboard video camera relays images from the cold, murky depths. The ROV moves into position. Everything's in place. The drilling can begin.
All right, let's go to work.
The drill bit leads the way. The crew must piece the drill together section by section. A forest of iron pipe stands ready near the central hole. Each section towers 93 feet high, dwarfing the workers below. In mile-deep water, it would take 40 pieces of this pipe screwed end to end just to reach the seafloor. This rig is designed to string together a maximum of 300 sections, 6 miles into the Earth's crust. At first, the work goes rapidly. In a single hour, the EVA 4000 sinks over 2,000 feet of pipe. In less than 3 hours, the drill bit will hover just above its target. Geologists picked this spot using 3D imagery based on sonar data. Their hunch is right. Oil should be directly below, 30,000 feet below. Now, it's up to the drill. Its job, dig a hole as deep as Mount Everest is high. Sand and soil billow out as the drill churns its way through the soft top layer. But below the silt, harder rock chews up a new drill bit every few thousand feet. 1,200 man-hours into the process, the drill crosses the 4,000-foot mark. But then, just as they're making steady headway, they shut down operations and pull up the drill. If the drill were to strike oil now, the petroleum would spew into the ocean. They have to cap the well securely before continuing to dig. The pressure is intense, below the sea and up on deck. If they fail to do the job right, it could lead to an environmental disaster. It's been weeks since Hurricane Katrina devastated oil production in the Gulf of Mexico. The oil crisis continues to heat up. Prices around the world have soared to record highs. And the U.S. government takes a drastic step, dipping into its strategic petroleum reserve to stabilize the supply. The eyes of the world's oil markets are on the Gulf of Mexico, waiting to see when the rigs will come back online. The EVA 4000 is still 26,000 feet short of its goal. Out in the Gulf, the men work day and night, but doing the job right takes time. And they are about to put into place the biggest and heaviest part of the puzzle, the blowout preventer. Nothing goes in or out of the well without passing through it. 50 feet tall, 500,000 pounds. It's loaded with monitoring equipment. The blowout preventer acts like an enormous spigot on the oil line, able to shut down the flow of petroleum within 15 seconds. The EVA 4000 must lower this monstrous piece of machinery onto the well pipe below. It's like trying to hit a 22-inch target from the top of the Grand Canyon. Specially designed tube called riser connects the blowout preventer to the rig. The riser provides a waterproof passageway for the drill and for chemicals needed to loosen and clear away the tough rock below. This much riser hooked to the blowout preventer weighs over 2 million pounds. Under normal circumstances, the derrick couldn't handle this much load. But engineers devised a simple way to make the deep water work to the rig's advantage. They wrapped the pipe in fiberglass to make it buoyant and to relieve the stress on the derrick. In just 24 hours, the blowout preventer nears its mark. It's a delicate moment. If the blowout preventer hits the well pipe, it could damage the opening and seriously delay the operation. The riser fights the deep-sea currents. The entire rig shifts its position, inch by inch, to find the right spot below. Success. The blowout preventer drops into place. Now, the drill can continue digging. All the effort and technology has led to this moment. Sketching the treasure map, setting the anchors, working the drill for 17,000 man-hours. Until now, no one was sure whether anything was actually down here. The drill doesn't stop. 10,000 feet. 20,000 feet, 30,000 feet below the sea floor. Oil. A geological treasure chest worth billions of dollars. The passageway is now clear. All the work has finally paid off. The The EVA 4000 has done its job. It found the petroleum 5 miles deep. But a drilling rig only drills. It doesn't process the oil. The EVA 4000 will move on to a different location in search of a new oil field. An even bigger super rig will move in to pump the oil out of the ground and send it back to refineries on shore. The processing platform could be anchored here for decades. Staying in one place, no matter what the Gulf sends its way. Its mission: extract the oil and natural gas from below the seabed. Separate out the impurities and send the oil and gas toward shore, 150 miles away. Rig builders had long struggled with the question of how to keep these giant steel islands anchored and stable in stormy seas and thousands of feet of water. Until pioneering marine engineer Ed Horton hit upon an ingenious solution inspired by his days on a Navy submarine.
You get in rough seas and, you know, it bounce around a lot. If you get down to 200 feet of water, that's the best place to be on a submarine, is under the water, not on the surface.
Horton's brainchild was the spar, a massive cylindrical hull, hundreds of feet long. The spar works because in the deep ocean, waves become smaller and smaller the deeper below the surface you go. A wave that's 25 feet on the surface may measure only 2.5 feet, 600 feet below. The spar floats far below the surface, most of its mass in contact only with these smaller deep water waves, keeping it stable even in rough seas. 1996, the Gulf of Mexico. A ship tows the Neptune platform into water nearly 2,000 feet deep. Crews fill the Neptune with seawater to make it heavy enough to tip. The spar design is brilliant in theory, but no one knows if this 12,000-ton cylinder will really work. After 10 years of design and construction, it takes all of 72 seconds to tip Neptune's 700-foot cylinder upright. It's one of the grandest engineering experiments the world has ever seen. It's an engineering triumph, and oil exploration will never be the same.
The first time I saw Neptune get upended was a great thrill.
Neptune's success marks a new era for deep water platforms. Soon companies are moving into even deeper water, building even bigger platforms that demand a new generation of spars. This is the state-of-the-art Gunnison platform, built to work in over 3,000 feet of water. The Gunnison will rest on a new generation of spar, the truss spar. Earlier spars had solid hulls. The new hull is solid for only about half its length. Its lower section is an open lattice structure with 3 horizontal plates. These plates trap water between them, creating a massive liquid cylinder that helps stabilize the structure. Its ingenious design allows less steel to hold up more weight. The Gunnison's 98-foot-wide cylindrical hull sections dwarf even full-size tractor-trailer trucks. They move 10 of these half-moon pieces into place. Huge tugboats pull the assembled Gunnison out to the well site. The spar floats over the spot where the drilling rig sunk the well. Workers flood it with water, and the Gunnison begins its plunge into the deep. After 23 hours, 14,000 tons of steel upends, perfectly stable. The spar extends 550 feet, about the length of the Washington Monument. The next challenge is keeping the spar in place. This platform must resist the forces of the Gulf for decades. Anchors like those used on the EVA 4000 won't work here. These spars will need something stronger. Specially made steel pilings designed to thrust deep into the sea floor. Footage markers indicate their full height, 220 feet. Engineers use these to regulate the depth of the pilings in the seabed. A support vessel lowers them into the Gulf waters. Once set, these anchors may be here long after the oil field below runs dry. With the anchors secure, the stage is set for one of the wonders of the modern age. A fully equipped oil and natural gas pumping platform will be set on top of the floating spar. It's a massive 3-story building that houses the oil pumps, processing equipment, and crew quarters. A giant crane must line up 4 touch points on the platform with corresponding points on the spar. The 10,000-ton structure hovers in the air like a spaceship over a fantastic landing pad.
You guys on the mat, get out of the way before you catch up. Is that okay with you?
Platform and spar pop into place like oversized toys. It's a perfect fit. The futuristic floating city is complete. This platform will pump and process up to 40,000 barrels of oil and 200 million cubic feet of natural gas every 24 hours. That's about $4 million of product every day from a single platform. The Gunnison requires only 24 workers to monitor the process round the clock. Machines do almost all the work. They extract crude oil from the rock and separate out the natural gas. The excess gas is burned. For 100 million years, this oil lay hidden, beyond the reach of man. Now, 21st century technology sends it hurtling towards civilization. A vast network of pipes on the seafloor carry the oil to refinery centers on the Gulf Coast. When it works right, it's routine and safe. But disaster can strike in the blink of an eye. And these super rigs can explode into deadly infernos. One of the most spectacular accidents in oil industry history showed just how vulnerable the world's biggest rig could be. March 2000. In the new age of deep water oil rigs, the Brazilian government launches the biggest ever. It's called the Petrobras P-36 platform. Once in place, it will pump 180,000 barrels a day and work in water over 4,400 feet deep. But in less than a year, this platform will become the Titanic of oil rigs. March 15th, 2001, 12:20 a.m. Natural gas leaking from a valve collects in one of the support columns. Alarms ring out as the odorless, invisible gas spreads further through the hull. And then, a spark ignites the trapped gas in a series of enormous explosions. The platform is listing 30 degrees in the Atlantic Ocean. 11 workers are dead. Rescue vessels scramble to save the remaining workers and the wounded platform. After 5 days, the P-36 plummets 4,500 feet to the bottom of the sea. The platform's a $500 million loss. Thousands of gallons of crude and diesel fuel flow into the ocean. The crew was able to seal the well before the platform sank, preventing a major environmental catastrophe. This time. But the P-36's fate is a reminder of the risks we take in chasing black gold farther and farther offshore. The stakes are impossible to calculate. The wells present a constant threat to the environment. A major oil spill from one of these rigs could destroy beaches, ruin marshlands, and kill wildlife. Cleanup costs from a major spill would run into the billions of dollars and take years to complete. Safety measures, technology, and training can minimize the risk of human error. But there are some factors beyond our control. Like where the oil reserves are located, in increasingly remote and dangerous places. 1/4 of U.S. oil production is based in the Gulf of Mexico, a danger zone for a full 6 months of the year, hurricane season. 3 weeks after Katrina, many oil platforms have gotten the oil flowing. But on the horizon lurks another storm, and the oil rigs are at risk once again. The EVA 4000 is drilling for oil over 100 miles out to sea when Hurricane Rita pounds its way out of the Caribbean. It's the most powerful hurricane ever recorded in the Gulf of Mexico. Rita's impact on land isn't as damaging as feared. But offshore, the toll, once again, is devastating. The storm tracks just far enough to the west to plow right through areas spared by Katrina. It's a 1-2 punch, making this the worst hurricane season in U.S. oil history. One casualty has a 20-foot gash in a main support column.
I knew what this rig was capable of, and when I came down here into the column and I saw this hole, I was just stunned at the magnitude of the damage.
It's unclear exactly what happened to the EVA 4000, but the huge hole is clear evidence of a colossal collision somewhere out in the Gulf. The superstructure's 3/4-inch steel is shredded like paper.
Just unbelievable. If you look here at the steel here, that how thick that is to take this kind of bend, it's unbelievable.
It will take weeks to fix the wounded vessel. but it survived the worst the Gulf has to offer so far. The toll for this one hurricane season: 115 platforms destroyed, 52 damaged. The big rig weathered the storm better than many. And come next hurricane season, the EVA 4000 will be out at sea, even farther from shore, in ever deeper water, pushing the boundary of what is physically possible, chasing oil to the ends of the earth and beyond.